Section 13.1 is line of best fit. So in topic number 2, we were talking all about one variable statistics. So we were looking at time or size or something that was just one thing that could change. Now we're going to be talking about two variable statistics. So we're going to be looking and comparing at two variables against each other, like time versus score, or your grade in English versus your grade in math, things like that. So one thing that we're going to be looking at is what's called inferential statistics, and that's where you take data, you analyze it, and you make conclusions about or infer conclusions about data that you did not collect. You can't prove these 100% for certain, but they're usually accepted to be true with a high degree of probability. So one way that we do this is with lines of best fit or linear regression. So we take our data point and we fit a linear equation with it to be able to make inferences or predictions. The way that we know how good our inferences are by our correlation coefficient, which we represent with the letter R. They tell you how correlated two variables are. So it ranges from -1 to +1. The closer to +1, the stronger positive correlation. The closer to -1, the stronger negative correlation. And the closer to 0, the weaker the correlation. So you want to think of it like a percentage. So the closer to 1 or -1 would be like 100% correlation. The closer to 0 would be like a 0% correlation. So if you got something like R equals 0.8, that would be about 80% correlation. So there's an 80% chance that these two variables are correlated to each other. So there's two ways that we can predict things, and that's with interpolation, which is predicting values within the data range that we already collected, and there's extrapolation, which is predicting data range or values that lie outside the data range. We can't use regression lines to predict for extrapolation because it's outside the information that we've already collected. So we talked about correlation. It's called the Pearson's product moment coefficient, or just the correlation coefficient. It ranges from -1 to 1. A perfect positive correlation would be R equals 1. A perfect negative correlation would be R equals -1. We say something is strong if it's between 1 and 0.8, strong positive if it's positive, strong negative if it's negative. We say it's moderate if it's between 0.8 and 0.6, again, positive if it's positive, negative if it's negative. It's weak if it's between 0.4 and 0.6, and there is no correlation if it's between 0 and 0.4. If there's no correlation, we do not construct a line of best fit. So if R is positive, then that means you have a positive slope, so that would be like this graph here. For instance, as the amount of time that you study increases, your score also increases. If R is negative, that means it has a negative slope. So for example, the amount of time you play video games increases, your score decreases, your test score decreases. So this would be a positive correlation, this would be a negative correlation. These next two slides of examples, I'll show you how to do them when I get back to class. They require graphing calculators, so I'll show you how to use your graphing calculator to solve these problems, and also how to properly draw a scatter plot. So here we have 4 scatter plots with varying ranges of correlation, and I would like you to rank them from a -1 correlation to a +1 correlation. Where would they fall? What order would they be? Remember, the closer, if it's negative, that means your slope is negative. If it's positive, that means your slope is positive. The closer to 1 or -1 means the better, more linear they are. The closer to 0 means the more cloud-like or less linear they are. So go ahead and pause the video and rank these in order of their correlation coefficient. So the closest to -1 would be D. It's negative and it's the most linear negative. Then moving towards 0 would be B. It's negative, but it's not as linear as D is. It's a little more cloud-like. This one here, C, would probably be pretty close to 0. There's almost no correlation between these data. It doesn't look like a line at all. And then A is positive because it has a positive slope, and it's pretty close to 1 because it's pretty linear. In this class, we'll be using our graphing calculator to calculate your correlation coefficient and your line of best fit. The only time you would need to be able to calculate it by hand would be for your internal assessment. That would need to be by hand if you wanted to get those work points for it. So for your correlation coefficient R is equal to S sub xy, which is called your covariance, and then divided by S sub x, which is your standard deviation of the x values, times x sub y, which is the standard deviation of your y values. So we learned how to calculate standard deviation back in topic 2. For your line of best fit, the slope is your covariance, S sub xy, divided by the standard deviation of your x's squared. And then x bar and y bar is the mean of your x coordinates and the mean of your y coordinates. So add them all up, divide by how many there are. So this has been 13.1, line of best fit or linear regression. When I come back to class next time, I'll show you how to do all of this on your graphing calculator, and we'll do those 2 example problems that we skipped.